Good morning, students. Before watching this video, please make sure that you have already watched 4 videos that I have uploaded. Last class, we have been discussing the various methods of solving the differential equations, and we are discussing the variable separable method. We have started exercise 8b also, and 2 Romans we have completed, and this is the third Roman. So the third Roman first question is dy by dx equals to 1 plus y square by 1 plus x square into xy. Solution. So by separating the variables, we get so cross multiplication, so y dy by 1 plus y square, y dy by 1 plus y square is equals to dx by x into 1 plus x square. Integrating on both sides. Integrating on both sides. We get integral y dy by 1 plus y square is equals to integral dx by x into 1 plus x square. So, integral y dy by 1 plus y square. So, 1 plus y square derivative is 2y. So, here 2 is lacking. Therefore, I will multiply and divide with 2. So that 1 by 2 into 2y dy by 1 plus y square. This is f dash x by f of x, log f of x. This is log 1 plus y square with additional y by 1 by 2 here. But as far as this is concerned, this is a fraction. This is a fraction, f of x by g of x, where g of x, the denominator contains the degree 3, x into x square, x cube. And here the numerator's degree is 1, that is x power 0. So 0 is less than 3. So degree of f of x is less than that of degree of g of x. Therefore, this is a proper fraction. For proper fraction, type number 1. So this is the denominator contains the linear factor x. This is of the form ax plus b. And this contains third type, that is irreducible quadratic factor. So let us do. See here, 1 by 2 into y dy by 1 plus y square is equals to integral 1 by x into 1 plus x square dx. So this is equals to, first, this is easy. Let us consider this. Consider 1 by x into 1 plus x square. So the partial fractions we can split it into x being a linear factor, which is a non-repeated linear factor, corresponds to this. One constant will exist, that is a by x plus 1 plus x square is not a linear factor like this. It's a quadratic factor. Which quadratic factor? Irreducible quadratic factor. What is irreducible quadratic factor? That factor which we cannot reduce further. We cannot split it into further factors. We cannot decompose. This is bx plus cy, which we have learnt in partial fractions in indefinite integrals. Under the heading partial fractions, we have learnt all these things by 1 plus x square. So this is equals to 1 is equals to a into 1 plus x square plus bx plus c into x. So taking LCM and cancelling x into 1 plus x square on both the sides, this is what we are getting. X being a linear factor for which may equate it to 0, then we will obtain one of the values of 3 constants, a, b or c. And we cannot equate x equals to something like this, because here the only linear factor is x. So this is irreducible quadratic factor comparing the quotient of x square or constant on both sides. So here let x is equals to 0, substitute 1 is equals to, here 0 into this is 0, so a into 1 plus 0, a into 1 plus 0, this is 1 into a, so a is equals to 1 here. Now comparing coefficients of x square on both sides. Then here quotient of x square is, there is no x square exists here in the LHS, therefore 0 is equals to a into x square. So x square quotient is a. A into 1a, a into 1a, which is a constant which we don't need. So a into x square, ax square. X square quotient is a. So this is 0 is equals to a into bx into x, bx square. So x square quotient is b. Cx is quotient of x, which we don't need. So here we are comparing the quotient of x square. So a plus b. So from this, if a is equals to 1, b is equals to how much? Minus 1. Likewise, comparing constants on both sides, we can even compare the quotient of x also on both the sides. Here the constant is 1 is equals to a into 1a. So next, again the same, a is what we are getting. Therefore, so instead of constant, comparing coefficient of x on both sides I will do. So here quotient of x is not there in the LHS, therefore it is 0 is equals to, here a into 1 is a, which is a constant, and a into 1 is a constant, so which we don't require constant here. Quotient of x we know we want, so here we are leaving it. Bx into x, bx square, which is not required, and c into x, cx. So this is c. C into x is cx. Quotient of x is c. So c is equals to 0 we are getting. Therefore, this 1 by x into 1 plus x square is equals to, a is 1 by x plus bx minus 1x plus c is 0 by 1 plus x square. So this is x by 1 plus x square is equals to 1 by x minus x by 1 plus x square. So now integral of dx is equals to integral of dx. So this is integral 1 by x dx minus integral x by 1 plus x square dx. Here 1 plus x square derivative is 2x, but here we have only x. So I will multiply 2 and divide with the 2. So this is integral 1 by x dx is log x minus 1 by 2. What is, this is 1 plus x square derivative is 2x. F dash x by f of x is log f of x. So log 1 plus x square. So now I will come to here. So this is equals to, now 1 by 2 integral y dy by 1 plus y square is equals to integral 1 by x into 1 plus x square dx. This is equals to 1 by 2. This is f dash x by f of x, or f dash y by f of y. Here 2 should be multiplied here, because y dy I just multiplied with the 2 and divided with the 2. Therefore 2 is missing here, which I have forgotten. So 2y. Now f dash y by f of y is log f of y. So log mod 1 plus y square is equals to, this is, what is integral 1 by x into 1 plus x square dx? log x minus 1 by 2 log 1 plus x square plus constant of integration is to be added, that is c. Instead of c, I have written to be log c. Now 1 by 2 log 1 plus y square plus 1 by 2 log 1 plus x square is equals to log x plus log c. So this is what we get. Now 1 by 2 into 1 by 2, if I take common, this is log 1 plus y square plus log 1 plus x square is equals to log x plus log c. Now this is equals to 1 by 2 log a plus log b, log ab. So log 1 plus x square into 1 plus y square is equals to log a plus log b, log ab, log cx. So this is equals to m log a, m log a to the power of m. So log 1 plus x square into 1 plus y square whole power 1 by 2 is equals to log cx. Now this is equals to log, if I remove on both the sides, then we will be getting this is equals to cx, that is root. The whole power 1 by 2 is root of, this is 1 plus x square into 1 plus y square is equals to cx, squaring on both sides. This is 1 plus x square into 1 plus y square is equals to c square x square. Therefore, the required general solution is 1 plus x square into 1 plus y square is equals to, instead of c square, which is a constant, we can even write capital C or k, whatever it is. So cx square, because if you remind the answer in this way also, it is correct. Otherwise, actually this is the textual answer. So I am telling you, the answers that we are getting at the end will be varied from the textual answers, because depending on the simplification of a student, okay, the problem's answer may vary. Okay, so not all the students get the same answer depending upon the simplification that he is doing. So dy by dx plus x square is equals to x square e power 3y. Dy by dx is equals to x square e power 3y minus x square. This implies dy by dx is equals to x square, if I take common, e power 3y minus 1. Now separating the variables, and integrating on both sides. This is equals to this is 1 by x square dx, or this is x square dx. X square dx is equals to dy by e power 3y minus 1. Dy by e power 3y minus 1. Again, dy by this is multiplying, it would be dividing here. E power 3y minus 1 is equals to dx into x square dx, and integrating on both sides, integrating. So we are succeeded in separating the variables on both the sides. LHS, on LHS variable x is there, on RHS variable y is there now. So here integral x square dx is easy, x cube by 3. So which we will do in a single step throughout the entire step. This is dy by, let us do, because e power 3y minus 1, how to deal this we don't know. E power 3y, if I take common, then this is 1 minus 1 by e power 3y. This is equals to integral x square dx is equals to 1 by e power 3y is e power minus 3y by 1 minus 1 by e power 3y is e power minus 3y whole dy. This is equals to integral x square dx is equals to, now here 1 minus e power minus 3y derivative, let us see. One derivative is 0 minus e power minus 3y. Let us suppose this to be y. E power y derivative is e power y itself. E power y is minus 3y into dy of minus 3y is minus 3. dy of minus 3y is minus 3. So here minus into minus plus. So 3 e power minus 3y should be on the denominator, for which so we want additional 3 with this e power minus 3y. So e power minus 3y, as I am multiplying with the 3, I have to divide with the 3 also by 1 minus e power minus 3y dy. So this is equals to integral x square dx is x cube by 3. X power, integral x power n dx is x power n plus 1 by n plus 1. This is equals to 1 by 3. We have just seen here. Its derivative is situated on the numerator. Therefore, this is f dash y by f of y, log mod f of y. So this is log 1 minus e power minus 3y. This is equals to plus constant of integration c. So that is log c I will take. Now this is x cube by 3 is equals to log, this is m log a to the power of m. So log 1 minus e power minus 3y whole to the power 1 by 3 plus log c. So this is log a plus log b, log ab. So this is log c into 1 minus e power minus 3y whole power 1 by 3. Again, log a plus log b, log a b is equals to x cube by 3. This is equals to, so if I am taking log here, then we will be getting e power x cube by 3 here is equals to c into 1 minus e power minus 3y whole power 1 by 3. So cubing on both sides we will do. So e power x cube by 3 equals to c into 1 minus e power minus 3y whole power 1 by 3. But this is not the textual answer. But if you stop the process with this answer, it is also correct. Otherwise, cubing on both sides will do. Cubing on both sides. This is equals to e power x cube by 3 whole cube. E power x cube is equals to, this is c cube into 1 minus e power minus 3y whole power 1 by 3 whole cube. This is 3 gets cancelled. This is what we get. Therefore, e power x cube is equals to, this c cube can be taken as k according to the answer that is given in the textbook. C cube is a constant. Let us take k as the constant. So 1 minus e power minus 3y is the required general solution. The third question is x square plus x dx plus yx square plus y dy equals to 0. Now, let us take x in common in both of them. Y square plus 1 dx is equals to this. On transposing, we get minus of. In both of them, take y as a common. Then we will get x square plus 1 dy. Now, separating the variables, and integrating on both sides, we get. So this is x dx by x square plus 1 is equals to minus y dy by y square plus 1. So now integrating on both the sides, this is equals to x square plus 1's derivative is 2x, but here only x is there, for which I will multiply. Otherwise 2x dx by x square plus 1 is equals to minus 2y dy by y square plus 1. What I did is, x square plus 1 derivative is 2x, therefore 2 is required here. Here y square plus 1 derivative is 2y, here only y is there. So 2 is multiplied on both the sides without loss of generality. Now, this is f dash x by f of x log f of x. So this is log x square plus 1. This minus, if you take to this side, now f dash y by f of y log f of y. So this is log y. Constant of integration is to be added, no? So here log c I will add. Instead of c, I will add the log c here. So this is equals to log a plus log b, log ab, log x square plus 1 into y square plus 1 equals to log c. Therefore, c is equals to x square plus 1 into y square plus 1 is the required general solution. The fourth question is dy by dx equals to 2y tan hx. This is equals to separating the variables and integrating on both sides. Integrating on both sides. This is equals to dy by y is equals to 2 tan hx dx. So here all y came on one side and all x came onto the other side, integrating on both sides. So this is equals to 1 by y integral dy. This is equals to integral 1 by y dy is equals to 2. This is tan hx can be written as sin hx by cos hx dx. This is equals to 1 by y dy is log modulus of y is equals to 2. Cos hx derivative is sin hx. So this is f dash x by f of x log cos hx plus constant of integration log c I will add here. Otherwise I can even add this log c here also, because if I want the textual answer I have to add on the LHS side. That is also correct, I am telling you. So now log A plus log B is log AB. So log modulus CY is equals to log M log A to the power of M. So log cos HX whole square. Therefore, CY is equals to cos HX whole square is H square X is the required general solution. Let us see this question. Sin inverse of dy by dx equals to x plus y. So, how can we do this? This is according to the inverse trigonometric function. So, dy by dx is equals to this sin inverse. If you transpose on this side, this is sin of x plus y. So, if I apply the formula here, sin of x plus y is sin x cos y plus cos x sin y. If you do so, then we won't be able to separate this into the variables. Therefore, let us take x plus y as a whole to some t. Let x plus y is equals to some t I will take. So, here dy by dx, that is x is the independent variable. Therefore, let us differentiate this with respect to x. Differentiating with respect to x on both sides. This is equals to d by dx of x is 1 plus d by dx of y is dy by dx is equals to d by dx of t is dt by dx. Therefore, from this, dy by dx is equals to dt by dx minus 1. Now, you try substituting this into this. Now, what is dy by dx that I got now? dt by dx minus 1 is equals to sine of x plus y is t. So this is equals to dt by dx is equals to 1 plus sine t. Now we can separate the variables here. Separating the variables and integrating on both sides. So this is equals to dt by 1 plus sine t is equals to, this is dx. Nothing is there, 1 dx. So integrating on both sides. Now this is equals to, let us multiply this with the 1 minus sine t here. So dt by 1 plus sine t into 1 minus sine t by 1 minus sine t is dt is there, integral 1 dx. Now this is equals to integral 1 minus sine t by a plus b into a minus b, a square minus b square. So 1 minus sine square t. 1 minus sine square t is cos square t. Cos square t dt is equals to integral 1 dx. This is equals to 1 by cos square t dt minus sine by cos is tan, 1 by cos is secant. So secant t tan t dt is equals to integral 1 dx. Now this is 1 by cos square is secant square t dt minus secant t into tan t dt is equals to integral 1 dx. Now, what is integral secant square t dt? Tan t minus integral secant square x tan x dx, integral secant x tan x dx, secant x. So this is secant t is equals to 1 dx is x plus constant of integration c. But we should not leave the answer like this, because the given equation is in terms of x and y. For our convenience, we have taken it to be t. So we substitute t back in the given x plus y. Therefore, it is tan of t is x plus y minus of secant of x plus y is equals to x plus t is the required general solution. dy by dx plus y square plus y plus 1 by x square plus x plus 1 equals to 0. dy by dx is equals to minus of y square plus y plus 1 by x square plus x plus 1. So separating the variables. Separating the variables and integrating on both sides. This is equals to dy by y square plus y plus 1 is equals to minus dx by x square plus x plus 1. So integrating on both sides. So here the variable x has been separated. The variables x and y are separated. Now this is equals to, this is y square plus y plus 1, which is the quadratic expression. So let us complete the squares too. Now here y square plus y plus 1 is equals to, this is y whole square plus y can be written as 2 into y into 1 by 2. So y square plus y is this I have written, plus here a square plus 2ab plus, so to become this into a plus b whole square, additionally b square is what we require. So additionally b square I want. That b square here is 1 by 2 whole square. So here y square plus y I have written it to be this. Additionally 1 by 2 whole square I have written. This I have written from our side. So since this is added, we need to subtract it also. Minus 1 by 2 whole square. Here plus 1 is same. Now what is this? A square plus 2ab plus b square is a plus b whole square. Here y square plus 2 into y into 1 by 2 plus 1 by 2 whole square. This is all a plus b whole square. This is y plus 1 by 2 whole square minus, this is 1 by 4 plus 1. So this is what I will write here also. So this is equals to, but instead of doing all these things, I'll just simply write 1 by y square, y you write simply, plus quotient of y is 1. So take a half of it, 1 by 2, complete the square here, minus 1 by 2 whole square is how much? 1 by 4 plus 1 you write as it is. So this is all the same thing. So instead of doing all these things, we can write here. If plus is there, plus you write. Here minus is there, minus you write. But here always minus only we have to write. So this is equals to dy is equals to same. Here also minus is there. 1 by, again, x square, you take x only. Plus, since here plus is there, plus only you have to take. Had it been minus, you would have taken minus here. So the quotient of x is 1. take a half of it, complete the square. Outside, minus you write and take a square of it and write here. So 1 by 2 whole square is 1 by 4, plus 1 is as it is here itself. So dx. This is equals to 1 by 1 y plus 1 by 2 whole square. 4 ones are 4 minus 1. 3 by 4. This is root 3 by 2 whole square we can write. Is equals to minus. So is the case here also. 1 by x plus 1 by 2 whole square plus root 3 by 2 whole square dx. Now, this is integral 1 by a square plus x square dx is 1 by a tan inverse x by a. So, we have the formula. So, likewise, 1 by a is root 3 by 2. 1 by a is 1 by root 3 by 2. That is 2 by root 3 tan inverse this by this. So, I will write here. So, 1 by a, 1 by root 3 by 2 tan inverse x by a, x here is y plus 1 by 2 by root 3 by 2. This is equals to minus same. Here also 1 by x square plus a square, 1 by a is root 3 by 2, 1 by root 3 by 2 tan inverse x by a, x is x plus 1 by 2 by root 3 by 2 plus constant of integration. So plus c you will take here. This is equals to 1 by root 3 by 2 is 2 by root 3 tan inverse. How much is this? 2y plus 1 by 2 by root 3 by 2. 2 gets cancelled, root 3 is equals to minus 2 by root 3, same tan inverse 2x plus 1 by root 3 plus c. Therefore, 2 by root 3 into 2 by root 3 into tan inverse of 2y plus 1 by root 3. This minus, if you transpose here, it will be plus 2 by root 3. 2 by root 3 is taken common. So tan inverse of 2x plus 1 by root 3 is equals to c. That is equals to tan inverse of 2x plus 1 by root 3 plus tan inverse of 2y plus 1 by root 3 is equals to, this is 2 by root 3 if you transpose on to the another side. So this is root 3 by 2 into c. That will be taken as c or k. This is the required general solution. This is the last problem from exercise 8b. dy by dx equals to tan square x plus y. So this kind of problem we have done earlier also. So let x plus y is equals to t. Differentiating with respect to x on both sides. This is 1 plus dy by dx is equals to dt by dx. Therefore, dy by dx is equals to dt by dx minus 1. Substituting dy by dx in the given equation, in the given differential equation. So this is dy by dx can be replaced as dt by dx minus 1 is equals to tan square x plus y is to be replaced as t. This is equals to dt by dx is equals to 1 plus tan square t. So this is dt by dx is equals to 1 plus tan square t. Secant square t minus tan square t equals to 1. So secant square t equals to 1 plus tan square t. This is secant square t. So this is equals to, so next here separating the variables and integrating on both sides. This is equals to dt by secant square t is equals to dx, integrating on both sides. Now the variables have been separated, t on one side and x on the other side. So this is equals to 1 by secant square t is cos square t. So cos square t dt is equals to 1 dx. Cos square t can be written as 1 plus cos 2t by 2 dt is equals to 1 dx. This is equals to 1 by 2 integral 1 dt plus 1 by 2 integral cos 2t dt is equals to 1 dx. This is equals to 1 by 2 integral 1 dt is t plus 1 by 2 integral cos 2t. Let us take this to be t. Integral cos x is sin x. So sin x is here 2t into by d by dt of 2t is 2. 2 2's are here 4 is equals to 1 dx is x plus constant of integration c. 1 by 2 into t is to be replaced with the x plus y. So x plus y plus 1 by 4 sine 2 into the value of t is x plus y is equals to x plus c. This is equals to 1 by 2x minus x plus 1 by 2y plus 1 by 4 sine of 2 into x plus y equals to c. This is equals to half x minus half. So this is minus x by 2. This is y by 2. So y by 2 minus x by 2 plus 1 by 4 sine of 2 into x plus y is equals to c. So here 4 is to be taken as an LCM. So 1 by 4 if I take an LCM, then this is 2y minus 2x plus sine of y is equals to c.